Hello everyone, my name is Auzi Asfarian. I will present our paper titled Towards Smart Mariculture Application, Providing Smart Monitoring System Mobile Apps to Support Grouper Cultivators in Kepulauan Seribu, Indonesia. This is the research from Department of Ilmu Komputer or Computer Science, along with Aquaculture Department of IPB University. And the authors include Irman Hermadi, Afriyadi, Yanuar, Rahmadani, Auzi Asfarian, myself, and also Professor Irzal Effendi. This paper is presented at IC-ICTRuDev2021, organized by Ministry of Communication and Information Technologies. So this is the required abstract of our papers. So you can read it on more detail in the conference proceedings. And basically in this presentation, I will deliver four parts. The first one is about introduction. We will talk about current condition and challenge of grouper cultivators in Kepulauan Seribu, Indonesia. Also, in the second part, we will dig deeper into the methods that we use to develop the mobile application, which is the software development life cycles. And also we will present to you the result and discussion, which include the overview of the process of development, the resulting application itself, and also the evaluation results, and also the conclusion of the works. So we would like to deliver our special acknowledgement to the Directorate General of Research and Development, Ministry of Research, Technology and Higher Education of Republic Indonesia, who has provided fund for this research through the grant titled Community-Based Mariculture Science and Technology Development toward Agro-Maritime 4.0. So this is the condition of the grouper cultivator in Kepulauan Seribu, Indonesia. So we work with the fish farming community called sea farming community that focus on grouper cultivation. This fish community is quite valuable and provide significant income to the both to the community and also for the local citizen. There are some problems that they are facing every day, which is timely monitoring of disease and water condition. This is very essential because grouper yield are really dependent on these factors. And currently, the current practice is to monitor the cultivation condition in person, and they take notes in the paper-based records. So the data is not really archived in good condition. And also it's really hard to know about the data in the timely manners. And it's also hard to process the data. And as we know, we can use that data to create automated monitoring system that can help the cultivator to combat or to monitor the disease and weather condition more perfectly. So in broader sense, what we want to achieve in the futures is about the smart mariculture. So basically, this is the works of Professor Irzal in the aquaculture department. So basically, using the mariculture, the smart mariculture, we can create higher yield productivity per area of the ocean. So for example, in the left side, we see that the natural maritime productivity is only 6 fish per 100,000 meter cubic. While if we treat them in good aquaculture condition, we can reach the yield of 60 fishes per 1 meter square, 1 meter cubic. So which is a drastic improvement of the productivity yield. And we can increase it more by implement several technologies which cover every cycle of the fish cultivation. And we can improve them with the computer science technology, so we can achieve the smart aquaculture system. Or in the broader sense, we can create the smart mariculture system, which is not only limited to aquaculture, but also involve anything in the ocean. So the aim of the research, because this is the first year of our research, is to creating the mobile apps first that can help the grouper cultivators to monitor the condition of the cage and assisting them and connecting them with IoT devices that can help them to record production activities and view production history. So we called the application as the K1000 or Kepulauan Seribu Smart Mariculture application. Of course, the scope is really limited, but we hope in the future we can replicate the result to other area. To create this, we use the software development life cycles, and we go to the group per cultivators area and do the interview. And also we talk and consult with fish expert to develop the models of the application, and also developing the software itself, and also testing them using the concurrent thing allowed methods. Also, although there are some things that we need to compromise because of the COVID pandemic, that make it really hard for us to go to the cultivator place. So this is the use case diagram. I think you can read this more clearly in the proceeding. So basically, we enable the group member and also group leaders to have action in the application. And this is the screenshot of the resulting application. So we create this as the progressive web app application. So we don't burden the phone of the cultivator that much. We also use the lightweight technology to make it easy to load. And also take a notice that there are some internet connection in the place, because we install them there as a part of our cooperation with them from IPB to sea farming community. And we developed the application using the REST API to communicate with each other. And we made it so it's really modular and easy to expand in the future. So this is the testing result from the usability testing. Sadly, we cannot test the application with the real cultivators, because it's really hard to reach them in the time of pandemic, and the internet connection is not clear enough to do remote usability testing. And there are also the gap of the knowledge and the gap of the technology literate. So what we do is that we try to reach the students that having experience previously to spend 2 until 6 months in the field, because there are also some students that do research in that area, in the cultivation area for several months as a part of their final thesis. So we ask them to do the usability testing instead, in hope that they having understanding about the problem, and also the assumption that about the characteristic of the cultivators. So based on the result, the testing, we get the 96.8% of task success from usability testing. But the actual number might be lower than this, because the student of course having a higher literacy level than the actual target users. So in conclusion, we already developed the front-end design and also the back-end design of the K1000 Smart Mariculture application that can be used by the grouper farmers in the Thousand Island to monitor the environmental condition in floating net cage and record production activities and view production history. So we evaluate this using the usability testing, and we get quite a good result. But again, there are some caveat of this number, which is we only testing it to the students, not to the actual user that have a lower technological literacy. So in the future, one thing that we want to do is after the pandemics end and it's possible for us to go again to there, we will do the re-examination or evaluation of the usability to the actual users. And also we will add more improvement to the application by connecting them to more monitoring devices in the smart farming, and also with including the analytics and also artificial intelligence. So, and at the end of the research, we will have a better mariculture application that can be used by the farming communities. Okay, this is the reference that used in this paper. So thank you for your attention. Nice to meet you. Assalamualaikum warahmatullahi wabarakatuh.